Hello, Psychonomics. I'm Julia Strand, but the real star of this project is Violet Brown, who is in the third year of her PhD program at Washington University in St. Louis. She did most of the work for this project, especially the hard work, and would be giving this talk if the rules of psychonomics allowed it. I want to start by pointing out that recognizing spoken language requires overcoming ambiguity at multiple levels. On a sensory level, the presence of background noise often obscures the speech signal, such that the source of a particular frequency becomes ambiguous. However, even in pristine listening conditions, there are one-to-many mappings between acoustic features and phonemic categorization. In addition, language is full of semantic ambiguity as well as syntactic ambiguity, which add even more complexity to processing spoken language. Yet, despite multiple sources of ambiguity, people are typically able to parse continuous speech rapidly and efficiently. How are we pulling this off?
Well, Julia, listeners make use of top-down cues to overcome the limitations of the bottom-up input.
Yeah, Violet. Listeners can make use of semantic, pragmatic, and grammatical context from early in an utterance to form predictions about upcoming reference or to reduce the activation of contextually inconsistent lexical candidates. For instance, given this visual display and the prompt, "The boy will eat the," listeners might show preference for edible objects like the candy and the pizza. It's important to note that listeners may make use of these kinds of contextual cues on different timescales. So first, listeners may use context to form predictions about upcoming words that they have not yet heard. In that case, we should see preference for edible objects even before the onset of the target word. In addition, listeners may use context to facilitate integration of the word into the sentence context after the bottom-up input from the target word has begun to unfold. So that is, contextual information may constrain how the incoming speech is interpreted. These effects should manifest as reductions in activation for items that are phonologically but not contextually appropriate after the word has started to unfold. So, for example, hearing "click on the candy" should lead to activation of both candy and its lexical competitor candle. But hearing "the boy will eat the candy" should lead to fewer fixations on the contextually inappropriate word candle. So this example concerns semantic context. We have knowledge about the kinds of things that can be eaten. But other research has assessed how pragmatic and grammatical context affects word recognition as well. The current study focused on grammatical context, specifically grammatical number, and how that affects word recognition. So in English, like many languages, listeners are typically required to specify whether a referent is singular or plural, and the accompanying verb must be conjugated accordingly. So for example, a speaker referring to this may say, "There is the beagle," whereas when referring to this, they would say, "There are the beagles." Thus, the conjugated form of the verb can be an informative cue about the upcoming referent. So listeners may use those cues to predict words before they begin or to constrain activation of the target after it has started to unfold. So the goal of the current study was to evaluate when and how listeners make use of contextual cues about grammatical number. We tested whether listeners use cues about grammatical number to predict upcoming words prior to target onset, as well as whether context reduced activation for phonologically but not contextually appropriate candidates. In this visual world paradigm study, participants viewed grids with 4 images as they listened to sentences, and we monitored their eye movements as the sentences unfolded. Each grid contained a target, in this example, beagles, a numerical lure that is phonologically unrelated to the target, archers in this case, which matches in number but not in phonology, a cohort competitor that was always a different number, in this case beaker, so it's similar in phonology to beagles but differs in number, and a distractor that is both phonologically and numerically distinct from the target, in this case archway. Participants were trained on the objects ahead of time so they knew that the target image was called beagles rather than, for instance, dogs. Participants saw 72 unique grids with no repeated images across the grids. Every participant saw each grid only once, but across participants, each word in the grid served as the target. Each grid was accompanied by either a numerically unconstrained set of instructions, "click on the," or a numerically constrained one, "where is" or "where are the." And participants were instructed to click on the reference object. We examined two different time windows. First, the anticipatory window was selected to represent the time point at which listeners had access to information about the verb is or are, but before they had processed any phonological information about the target. So this window will tell us whether listeners can use context to predict upcoming words even before they've started. The cohort window represents the time in which listeners had access to phonological information about the target as well. So that window will let us answer questions about how phonological information is integrated with context. Note that here and throughout, the analysis windows are slightly offset to account for the time it takes to program and launch an eye fixation. So first of all, we checked to see whether we replicated classic cohort effects in the grammatically unconstrained context. Here and throughout, I'm going to be using the example target word beagles. So in this case, the sentence is click on the beagles, but the data shown represent all of the items. So before target onset, participants fixated on each of the 4 objects about 25% of the time. After target onset, fixations to the target steadily rise. Fixations to the cohort competitor briefly rise, then fall as the target word unfolds and the competitor becomes disambiguated from the target. And fixations to the 2 phonologically unrelated words remained low. Just as we would expect, sanity check supported. The anticipatory analysis was conducted exclusively on grammatically constrained trials, because the purpose was to assess whether participants make use of the copula, is versus are, to guide anticipatory eye movements prior to target onset. The gray region here represents that anticipatory window, which extends from the onset of the copula to the onset of the target, slightly offset. So fixations to the target steadily rise, which makes sense because it has both grammatical and phonological support. Fixations to the distractor, which is not phonologically or grammatically consistent, consistently fall. The cohort competitor follows the distractor in the anticipatory window, but then there's a little bump as the phonologically similar target unfolds. But the really interesting question is, what's going to happen with that grammatically appropriate lure? Are participants going to use the form of the verb to anticipate it? Check it out. They do. So as expected, participants fixated on objects that were consistent with the grammatical context even prior to target word onset. So for the analysis, we built linear mixed effects models to test whether participants showed a greater proclivity to fixate on plural objects when the context suggested that the final word would be plural. And as predicted, we found a tendency to look at plural objects when the verb is are rather than is. Thus, even prior to target word onset, participants were more likely to fixate on objects that were consistent with the grammatical context than those that were not. In the next set of analyses, we assessed whether the presence of numerically constraining information in the carrier phrase could influence lexical competition during processing of the target word. So we're testing how phonological information from the target word is integrated with the preceding context. Note that we've zoomed in on 0, so the x-axis now indicates the onset of the target word, and the gray region is the cohort window. So first, let's look at what happens in the grammatically unconstrained context. Here we're showing those classic cohort effects again, but leaving off the lure for simplicity. The shaded region here represents the comparison that we are interested in for this analysis, the difference in fixations to the competitor relative to the distractor. As the target word unfolds, people look at the phonologically similar word more than they look at the unrelated word. Now let's compare this pattern to the grammatically constraining context. So there's a systematic change in what is fixated on when we add grammatically constraining context. Again, the key comparison here is how fixations to the competitor differ from those to the distractor. Remember, these competitors are phonologically similar to the target, but they are not consistent with the context. But what you can see is that the teal shaded region, the preference for competitor relative to distractor, is smaller than the black shaded region. This tells us that the preference for the competitor was smaller in the grammatically constraining context because the competitor was inconsistent with the grammatical number indicated by the sentence. So in our previous example, when participants heard click on the beagles, they're more likely to look at the singular beaker than if the instructions were, where are the beagles? And the number is specified. It's also worth noting that even in the constrained condition, participants are still looking at that phonologically appropriate but grammatically inconsistent cohort competitor more than they are looking at the distractor. So this tells us that the numerical context reduced, but didn't entirely eliminate activation of the numerically inappropriate cohort competitor. So to recap, we found that listeners do make use of grammatical number for both anticipating upcoming words and integrating them with the preceding sentence context. This is consistent with the continuous integration view of speech processing, which states that listeners use all available bottom-up
and top-down
cues when processing continuous speech, and immediately and continuously integrate information from these sources to guide speech perception. Importantly, we also showed that activation of contextually inappropriate competitors persisted above the level of the distractor objects. These results suggest that listeners rapidly and flexibly make use of contextual cues about grammatical number while maintaining sensitivity to the bottom-up input. We're grateful to the people who paid the bills and to the research students in the Carleton Perception Lab. You can access our data, code, pre-registration, and the preprint of this manuscript on the Open Science Framework. Thanks for tuning in, and I look forward to answering your questions.